This is section 12.1, and if you had Math 1324, the previous course, you should have possibly been exposed to the definition of a derivative in chapter 11. And so we pick up in 1325 with calculating derivatives, and the derivative is simply the slope of a tangent line. It's instantaneous rate of change. And that's different from the slope that you're used to in algebra, where it was a constant. The slope was the same all along a line, but we begin to be able to take slopes of curves at particular points. So that's just a backtrack of chapter 11 at the end when we maybe talked about that. There's some various notations for derivative for y equal, if you're looking at y equals f of x, this f prime of x, where you have this little like apostrophe here, that's a common one. dy slash dx, d dx of f of x, and big dx of f of x. Those are all different, some notations. I tend to use the f prime of x, so you'll see me do that more than the others. So we're going to talk about some rules, and then we'll go over the problems from the problem set. So the first rule is the constant rule. And if your f of x, if your function is a number, a k, then the derivative is always 0. That's an easy one. So looking at these examples, if your f of x is 8, g of x is pi, y equals 2 to the e, all of these are just constants. Those are numbers. So the derivatives of every one of those is 0. Then we have the power rule. The power rule means if you have a function where an x is raised to a power, then the rule says f prime of x is, now you take that in, whatever that power is, and bring it to the front here. So that's this. And then this n becomes n minus 1. You take 1 away. So that's the general rule. Let's look at some examples. So if we have y equals x to the 6th, then y prime is, the 6 comes to the front, we take 1 away from 6, that's 5. So the derivative is one level down on the powers. F of x is x to the 4/3. So f prime of x, bring the 4/3 to the front, take 1 away from this. Well, if you're taking 1 from 4/3, that's like taking 3/3. So you end up with 1/3. So 4/3 x to the 1/3. Y equals z to the 1/2. Y prime, bring the 1/2 to the front. Now we got to take a whole 1 away from this 1/2. So if you're taking away 2 halves, which is 1, then you're going to have a negative 1/2 here. So those are some general examples. In 12.1, those are the rules we're going to see, the constant rule, the power rule, and then there are some, go ahead and maybe write these down whether we have them in this section or not, as far as some application formulas. When you talk about the cost function of something, and then that's the cost, and that would have to do with revenue and profit. And so the cost, if you talk about marginal cost, that's the derivative of the cost function. If you're talking about the revenue function, marginal revenue is r prime of x. So you're taking the derivatives. Anytime you're talking about marginal, you're taking the derivative. The profit function would be revenue minus cost. That's how much profit you have. And so then marginal profit would be p prime of x. Now, I think we do encounter these in one of our problems at the end of our set. So when you talk about position, talk about physics, position function is usually s of t, s of t. The velocity function is the derivative of that. So v of t is the same as s prime of t. The acceleration function, a of t, is the second derivative. So you take the derivative of this velocity, and that gives you the acceleration. So s of t, s prime of t, s double prime. And we will see some of that in our problems. So let's go look at the problem set and see what we have. So here we have number one. And number one, these just say find the derivative. And so I haven't shared the typed part, but this is what the function is in your problem set. So you have y equals, and it's a cubic function. When you have a polynomial like that, you're just going to take the derivative of each part. So x cubed, the derivative would be 3x, and then take away 1, so that's 3x squared. When we have this, there's already a number here. So we're going to take this 2, multiply it by 16, and then take 1 away. So that becomes 32x. Now, 45x, let's think about that. There's a 1 understood up here. 1 times 45 is 45. When you take 1 away from 1, you get x to the 0, which is just the number 1. So anytime you're taking the derivative of an x, it becomes a constant. And remember, the derivative of a constant is 0. So our final answer is written here. Okay. Number 2, y equals x cubed minus x squared over 64 plus 45x plus 9. This is the piece that is different. So my suggestion is to rewrite things like this so it's easier for us to work with. So we have x cubed minus, and we're going to put this 1 that's up here over the 64 and put x squared by itself so that we have a number in front of x squared plus 45x plus 9. So then we're going to go through and take the derivative of each piece. So 3x, take 1 away, so we got 3x squared minus 2 times this is 2 over 64, which reduces to 1 over 32. X, take away 1, so we have a 1 there, plus the 45x, derivative of that just becomes the constant, and the derivative of 9 is 0. Now, typically, they may take the answer just like that. I've put it back in the form it was in to start with, where the x was over the 32 or the x squared was over 64. You could try this, see if the answer will take it. If not, this one, but if not, then put it back in the other form. I think it probably will take either one. All right, number 3, y equals 5x to the negative 6 minus 4x to the negative 1. Same rules apply, but we've got negative exponents, so we have to be careful. Negative 6 times 5 is negative 30. Now, when you take 1 away from negative 6, it becomes negative 7. Then here you have to be careful because negative 1 times negative 4 becomes a plus 4. Take 1 away from this, it becomes negative 2. So this is our final answer. You just have to be very careful with your signs. All right, number 4. Y equals 5 over x squared minus 9 over x. So I'm going to rewrite that just like we did up above. So this one's going to become, now let's think about this. If I don't want this in the bottom of the fraction, when it comes to the top, that positive 2 exponent becomes a negative. So this is y equals 5x to the negative 2 minus 9x to the negative 1. We do that so we don't have these fractions. Everything's all on one line, and that makes it easier for us to take the derivative. Y prime then is negative 10x to the negative 3 plus, because here we're multiplying negative times negative, so plus 9x to the negative 2. It might take this form. If not, we're going to put the x cubed on the bottom, and when we move position, we change the sign of the exponent. So that becomes a positive x cubed, just like that right there. Plus 9 over a positive x squared, or x to the positive exponent. So you could try either one. Sometimes it does not want the negative exponents in your answers. So you'll just have to see what form it requires in the computer. All right, y equals negative 5 over the cube root of x. So there's an understood 1 there. I wrote that in. And over here, I'm showing you that the cube root of x is the same as x to the 1/3. So we've got to be able to go from radicals to fractional exponents. That's going to be helpful. So when I rewrite this thing, I have my -5. This was on the bottom as x to the 1/3. So when I bring it to the top, it becomes x to the -1/3. So you have to think about that. Down here, it was a positive x to the 1. This exponent was positive. When we bring it to the top so that we don't have this fraction, that has to change to a negative. All right, now when we take the derivative, -1/3 times -5 is a positive 5/3. X to the, and I've shown you that here, -1/3 minus 1, which is 3/3, becomes -4/3. And there is our answer. So 5/3 x to the -4/3. A lot of algebra happens here. And usually what I say is the calculus doesn't do you in. Sometimes it's the algebra. So if you need to brush up on some algebra things, that may be helpful. All right, number 6. H of x is equal to x to the 10th minus 2 to the 3rd power. If you've had any calculus before, you know there is a shortcut to this, but we don't know that yet. So we'll get that in another section. Right now, we've got to go ahead and expand this. This times this times this. That's to the 3rd. So here is just algebraic. I'm going to FOIL these out. So x to the 10th times x to the 10th gives you x to the 20th. Then you have minus 2x to the 10th minus 2x to the 10th. So that's a minus 4x to the 10th. And then -2 times -2 gives you 4. So now I've got this thing times another one of those. I'm going to multiply x to the 10th times all of this. So I get x to the 30th. Remember, you add exponents when the bases are the same. Minus 4x to the 20th plus 4x to the 10th. Then I'm going to multiply my minus 2 times all those pieces. And I get minus 2x to the 20th plus 8x to the 10th minus 8. Combine like terms, and you had -4 of these and -2 of these, so we have -6x to the 20th. We had 4 of these, 8 of these, so we have plus 12x to the 10th, and then a minus 8. All of that was just to get this ready for us to take the derivative. Now, let's take the derivative. 30 goes to the front. That becomes 29. So we have 30x to the 29th. 20 times minus 6 is minus 120. X, take 1 away, to the 19th. 10 times 12 is 120. X to the 9th. Derivative of that is 0. So your final answer is here in the box. All right. Number 7. A little bit of work on this one. Number 7 says find the slope and the equation of the tangent line. So the slope of the tangent is the derivative. So if we're going to take the derivative of this right here, we get 4x cubed minus 34x. That is the generic, if you would. This is f prime of x. That is the derivative. Now, it says find it at x is -1. So if this is f prime of x, then f prime of -1 means we plug in -1 for x. When we do that, we get 30. So we now have the slope at x equals -1. When we write the equation of a line, you need 2 things. You need the slope and you need a point. Well, we've got the slope. We have an x value of a point. We don't have the y part of the point. So if x is -1 and you plug -1 in here, you should get 0. So your point would be -1, 0. All right. So if you plugged it in, you would see you're plugging in your -1 in the original. So if you get that there, that'd be 1. You plug it in here, that'd be -17. So this is 1 minus 17 would be -16 plus 16, we get 0. All right, so to write the equation line, you need slope and a point. Your slope is 30, that's m. Your x part of the point is -1. Your y part of the point is 0. So this is the point slope form of an equation. We're just going to plug these pieces in. Y minus 0 equals 30 times x minus a -1. So that becomes x plus 1. Go ahead and distribute. You get y equals 30x plus 30. That's the second part of that question. It wanted to know the slope, and then it wanted to know the equation of the tangent line. So that was the two parts. Number 8. Number 8 gives you this function and says, where is the tangent line horizontal? Tangent, the slope of the tangent line. Think about that. And remember that slope of a horizontal line is 0. Slope of a vertical line is undefined, but horizontal, it's 0. So we need to find the derivative of this thing and then set it equal to 0. That will give us the x values where the tangent is horizontal. So f prime of this 6x squared, 72x plus 192. Now we're going to set that equal to 0 and solve it. That's a quadratic. I looked at this and said, okay, I'm going to factor out 6. 6 should go into all of those. I did that. That 6 just goes away because you can divide it into 0. Now we're going to factor this. X plus 4, x plus 8. 4 times 8 is 32, and 4 plus 8 gives you 12. So that works. So when you set both of those equal to 0, you get x is -4 or x is -8. Those are the two places where our tangent line is horizontal. So that would be your answer for number 8. Number 9. Number 9 gives you a position function, 19t squared minus 14t plus 6. And I believe it wants you to find the velocity. The velocity is the same as s prime. So take the derivative of this. You get 38t minus 14. And then it gives you 3 values. What's v of 0, v of 5, v of 9? You are just plugging in those numbers here for t. And this is what you should get. -14, 176, 328. You're just plugging in for t there. All right. Number 10, last one. It gives us a position function. S of t is equal to -16t squared plus 155. What is the velocity 1 second after the drop? All right, so velocity, remember, is the derivative of the position. So if we take the derivative of this, we get -32t. That goes to 0 because that's a constant. So that's the velocity. And they want to know v of 1. Plug in 1 for t, and the velocity is -32. When will it hit the ground? When will this position thing hit the ground? Well, position on the ground is 0. So take the original position, set it equal to 0. -16t squared equals, subtract the 155 over here. Now, if you divide -16 over there, you get t squared. You've got 2 negatives, so this becomes positive. You can go ahead and take the square root of this on the calculator, and you get 3.1. So after 3.1 seconds, this object will hit the ground. Okay, so that's how long it takes to hit the ground. What is the velocity upon impact? Well, impact occurs when you hit the ground. So remember, our velocity was -32t, and we know we're going to hit the ground at 3.1. So we're going to have -32 times 3.1. So v of 3.1 is -99.2. And that will be the answer to that. So there's 3 parts to number 10. And that should get you through the problems when you're ready to do the homework. They should mirror these problems, so it should get you through.